Draw a graph of 3x minus 5y equals 10. So we need to draw the graph because before that we were given ordered pair and it was easy to draw those points on this Cartesian plane, and then we could only join those points through straight lines. But now we are given an equation like this and we need to draw a graph of this equation. It's easy because we need to find x and y points, the ordered pair, and it's easy to make it from this equation. But we need to do some algebra before that because I want to modify this, not modify, just change the arrangement of variables in this equation. For example, I want to put y on the left side and x on the right side so that I can get the y and corresponding x values. So I will bring this 3x side to the other side. So it will become negative 5y equals 10 minus 3x. So I have subtracted 3x on both sides. So this will cancel out with the negative 3x, and then negative 3x will appear on the other side. Now I want to isolate this y on this side. So I will divide both sides with negative 5. So it will become y equals 10 divided by negative 5, then negative 3x over negative 5, because I am dividing the whole equation with negative 5. Now rest is easy, is equal to, when I will divide 10 with negative 5, it will become negative 2, because when you divide anything with a number which has negative sign will appear here, or you can use your scientific calculator, it will tell you. Similarly, it's same, this when I will divide this 3x with the negative 5, the negative sign of the 5 will cancel out with the negative sign which is with the 3x. It will become plus 3 over 5x. Now, every time when you are given equation, try to make it in this format. You have y on the left side and rest of the quantities on the right side, whether they are constants or x or whatever variable is involved. And you will be given an equation with only two variables, and those variables will be in a linear relationship. It means the graph, because when we will draw the graph of this equation, it will be a straight line. And if you are given in an equation which is linear, meaning the graph of that equation is a straight line, you only need to have a two set of ordered pair, and that's enough. So for example, now I want to get the ordered pair. So here I will develop, I will make a table of ordered pair. I will have my y value here, and I will write my corresponding x value here, because I need to have x and y values to draw on this Cartesian plane. So now it's the choice is yours. You can choose any value of y, and then you will put that value in this equation and find the corresponding value of x, and that will be your value. For example, so what value should I choose? The choice is totally arbitrary. You can choose any number, but just think that choose the number which is convenient for you. For example, I would like to have y equals 0. I just choose this value. If y is 0, now I need to put the y equals 0 in this equation to find the corresponding value of x. So if y is 0 equals negative 2 plus 3 over 5x. So now this 2 will shift to the other side. It will become 2 equals 3 over 5x. And what do you think will be the value of x? X will be, this 3 over 5 will become 5 over 3 multiplied by 2. And then the value of x is 10 over 3, because I have to draw to um, make this point on the graph, so I need to have the value in, not in the fractional form, but in decimals. So my calculator tells me that x equals 3.33. So for y is equal to 0, the corresponding value of x is 3.33. Now I need one more ordered pair to draw the graph, because one point is not enough. I should have at least 2 points if it is a straight line graph. So what should be the other ordered pair? I have a guess. For the first ordered pair, I chose y equal to 0. So maybe I can think x equals 0 for the second ordered pair. And when this is the main equation, so when I put x equals 0 in this equation, y will become negative 2. So here y is negative 2. So now it's time to draw the graph of this equation, because I got two sets of ordered pairs. So they are enough to draw the graph of this equation. So I will draw the first ordered pair. So y is equal to 0. So if it is 0, it should be at the origin. And now x equals 3.33. I know here is 3, but I can't locate 3.33. You see? So it's a problem, because here is 3, but I can't locate 3.33. So let's do it at 3, because I don't have any choice. So here is the point 0 and 3, 3. Now go to the next ordered pair, 0 and negative 2. So once again, x is 0, so I will start from the origin, and y is negative 2. I will go down. Here is negative 2. Okay, so I have located the 2 points, although the point A is not very precise, because it is actually 3.33. But I placed it at 3 because my graph paper doesn't show the values um, in the fractions. So these are just whole numbers, 3 or 4. So now it's time to draw the graph of this equation by joining these two points through a straight line. So I start from B and I will end at A. So here is point A. So this is the graph of this equation, but it is not very precise, you see, because point A is at 3, and according to my ordered pair, the point is 3.33, so it should exist somewhere here. But because my graph paper, the resolution of my graph paper is not that much, so that it shows the values in the fractions, so I have no choice. But what do you think? Can I avoid to have a value in the fraction like this? Because you see, for the second ordered pair, it's very nice, 0 and negative 2, and it was so easy to locate this point, the point B. But for the first ordered pair, unfortunately, I chose a value for the y as 0, but I got the value of x in fraction 3.33, and I am unable to locate this point very precisely. So what do you think? Can I get can I do something to get an ordered pair with whole numbers and not in the fractions? So let's try again. This time I don't want to get any value in fractions. So what you think, what should I do to get the first ordered pair without any fraction? I want to get whole numbers like the second ordered pair. So what should I do? Maybe if you see, the only problem is this 3 over 5 term with the x, because this term makes fractions. So what if I choose x, the value of x as 5? Because if I choose the value of x as 5, that 5 will cancel out with the 5 in the denominator, and then whole equation is fine, right? So for the first ordered pair, let's see if I choose x is equal to 5 and then y equals negative 2 plus 3. You see, because if I put 5 here, this 5 will cancel out with the 5 in the denominator on the left side term. So this will become negative 2 plus 3, and if I solve this expression, it will become y equals 1. You see, just by choosing the value of x intelligently, I can avoid getting a value or ordered pair with fractional terms. And that is nice. So whenever you want to draw a graph of an equation, because then now you have the choice to take the ordered pair, any ordered pair you want, just choose any value of one variable and then find the corresponding value of the other variable and you will get an ordered pair. But now because you have the choice, choose it carefully and try to avoid any fractional numbers, because then it's hard to locate them on the graph paper or the Cartesian plane. So now let's try it. I already have point B, negative 2 and 0, but now I will locate 1 and 5 points. So 1 and 5. So x is 5. So I will go horizontally. Here is 5. And then I will go up at 1. By the way, before locating the point, let me tell you that the way I have developed this table, I wrote y first and x second. But when you will write them as ordered pair, write them as 5, 1, because the convention we use, we usually write x value first and then y. And then similarly 0 and negative 2. So this is how we write ordered pair. And now it's time to locate the point. 0 and negative 2 is already there as point B, but now I will locate point 5 and 1. So first I will go horizontally along the positive x direction in front of 5, and then I will go up and I will just stop where the y is 1, because now I have whole numbers. I don't have any problem to locate that point, and here is point C. So see, the point C is here. So now to draw the line, point B is the same, right? And I will join point B with point C, because C is the correct point. The point A was wrong because for point A I had a fractional value of x 3.33 and I was unable to locate that point. But as you see, just by choosing the right value, I am able to get the whole numbers, and now it's easy to locate the point. So now I will join point B to point C. So now this is the correct graph of equation 3x minus 5 equals negative 10. I did that to realize you that the fractional number will cause an error. You see the first line, this where I have just put the point D, this line has a problem, you see, because that point is different and that line is not the graph of this equation. You just got an error because the point A, I just chose chose a value where I got a fractional value of a 3.33 and I was unable to to locate that point. Now just by choosing a correct or the right value, so that I did not get any fractional value, I got whole numbers, and I was able to draw the graph of equation 3x minus 5 equals negative 10, and this is that line, and this is the correct line. So whenever you want to draw the graph of an equation, choose the values carefully so that you get the whole numbers. Of course, it may not be possible in some situations, or you can't avoid this. Then in that case you can get the fractional value and draw the line like I did that. Just convert the fraction into the whole number by estimating, and then you can draw the graph on the examination paper, because fractional values are hard to draw, especially on the paper, or if the resolution of your graph is not that good. If we don't have any small lines here, then it's hard to draw the fractional values.